In 1926, Picher, Oklahoma had 14,252 people. Its mines employed more than 14,000 men and had supplied over half the lead in zinc America consumed during World War I. By 2010, the census found 20 people. The government had paid residents to leave a town with lead-contaminated waste piled 200 feet high beside its homes and unstable mine cavities beneath its streets. Long before anyone called the place Picher, the ground at the northeastern corner of Oklahoma had already been divided, promised, surrendered, and divided again. There were no streets, no mills, no mine whistles, and no mountains of crushed white stone. There was a narrow piece of Indian territory pressed against Kansas and Missouri, drained by the Spring and Neosho rivers, with Tar Creek running south through the limestone country. Beneath it lay something no boundary line could contain. The Quapaw called themselves the Ogapa, the downstream people. Their older homeland lay hundreds of miles east, around the lower Arkansas River and its meeting with the Mississippi. During the first decades of the 19th century, a series of treaties reduced that homeland and moved the Quapaw first onto land along the Red River, then away from it. In 1833, they relinquished their claim there in exchange for 150 sections west of the Missouri state line. The following year, fewer than 200 Quapaw reached the new reservation in what would become northeastern Oklahoma. It was a small corner of a country that had not yet become a state. The Kansas border formed its northern edge. Missouri lay just beyond the eastern line. The rivers offered water, but not a route to an ocean. There was no large city nearby, no university, no state house, and no market that could explain why thousands of people would eventually crowd onto this ground. The explanation was already beneath them. The rock holding it was known as the Boone Formation, a broad layer of limestone and chert formed hundreds of millions of years earlier. Inside fractures and cavities in that rock were deposits of galena and sphalerite, the minerals from which lead and zinc could be recovered. The richest deposits in Ottawa County lay near the place where Picher would later stand. Nothing on the surface announced their scale. The prairie did not smoke. The creeks did not carry metal bars. A person could cross the land without knowing that one of the richest sections of the tri-state mining district rested below his boots. By the late 19th century, the federal government was changing the meaning of the land above it. Across Indian Territory, communal tribal holdings were being broken into individually owned allotments. The policy converted a shared territory into measured parcels with names attached to them, while federal rules continued to restrict how many native owners could sell or lease what had been assigned to them. The Quapaw attempted to shape that process before it shaped them completely. In March 1893, they agreed to divide their land into allotments of 200 acres. Additional 40-acre parcels followed in 1894. The arrangement gave individual Quapaw owners more land than the smaller allotments that federal policy might otherwise have imposed. It also placed a new grid across the reservation. That grid would matter, or did not stop at the edge of a 200-acre allotment. It did not recognize inheritance, federal supervision, or the line between Oklahoma and Kansas. A mineral body could pass beneath several owners, while every company seeking to reach it needed leases and government approval. Later, those legal divisions would help determine where shafts were sunk, where mills were erected, and where piles of discarded rock accumulated. Before Picher had a town plan, part of its industrial geography had already been drawn on allotment papers. One of those parcels belonged to a Quapaw allottee named Harry Crawfish. Very little in the later appearance of the city would preserve that fact. The town would not take Crawfish's name. The largest companies would arrive with names belonging to men in Missouri and corporations headquartered elsewhere. Ore cars would leave carrying lead and zinc into a national market. But the strike that created Picher would be identified in Oklahoma's historical records by the land beneath it, Harry Crawfish's allotment. Mining was already moving toward him. Lead had been worked in southwestern Missouri for decades, and the productive field had spread into southeastern Kansas and northeastern Indian Territory. Towns such as Joplin and Galena had shown what could happen when a drill entered the right rock. Timber derricks appeared. Rail spurs followed. Farmers and landowners began to receive offers from men who were interested in what lay several hundred feet below the soil. The arrival of mining did not always begin with a mine. It began with a signature. A lease gave a company permission to test a parcel. A drill crew followed with lengths of steel, a derrick, an engine, and enough determination to keep boring through limestone that looked no different from the stone beneath the next field. Most holes found nothing worth building a town around. Their locations survived, if at all, as entries in a company ledger. Records disagree over exactly when the decisive discovery near Picher occurred. Oklahoma historians place the strike on Harry Crawfish's allotment in late 1913. A federal historic property record describes a Picher Lead Company drilling rig making its major discovery near Tar Creek in August 1914. The disagreement is appropriate for a town that grew faster than its early history could be written down. What is certain is that the land had already been prepared for what followed. The reservation had been divided. The individual parcel had an owner. The mining district had reached the edge of it. The company had a lease, and the drill was coming down through the Boone Formation. Above ground, there was still no Picher. Below it, the reason for Picher was waiting. One version of Picher's beginning starts with a drilling rig that could not get home. According to a federal historic record, the rig belonged to the Picher Lead Company and was returning toward Joplin after disappointing work near Commerce. Somewhere near Tar Creek, it became stuck. The crew was sitting above land that had already been measured into allotments, but had not yet been organized into a town. Rather than leave without testing the ground, the drillers sank a wildcat hole where the machinery had stopped. The bit went down through the Boone Formation. What it found changed the map. The surviving accounts do not agree on the exact year. Oklahoma historians place the important strike on Harry Crawfish's allotment in late 1913. Federal environmental and historic records place the major discovery in 1914, with one giving August as the month. Some later versions describe Harry Crawfish himself as the discoverer. Others give the decisive act to the company's drill crew. The disagreement appeared early enough that a Picher newspaper would later observe that the true beginning of the town was difficult to determine. There is no disagreement about the ore. The drill had entered a rich body of lead and zinc beneath the northeastern corner of Oklahoma. Smaller discoveries had already been made elsewhere in Ottawa County, near Peoria in 1891, Quapaw in 1902, and Commerce in 1905. Those deposits had extended the mining country westward from Missouri and Kansas. But the strike near Tar Creek was different in scale. It opened the most productive portion of the entire tri-state field. The Picher Lead Company moved quickly. One federal account states that it leased approximately 20,700 acres around the new discovery. That was not a single uninterrupted property purchased from one owner. It was land assembled through mineral leases in a reservation that had been divided among Quapaw allottees and their heirs. Each agreement carried names, boundaries, restrictions, and federal oversight. The ore below ran through all of them without interruption. Above ground, the 40-acre tract became the working unit. Mining leases in the Picher field were commonly arranged so that a reduction mill would stand on each 40-acre parcel. A mine company could not simply sink one shaft and treat the whole district as a single underground property. Different tracts meant different leases, different access points, and eventually different mills. The arrangement would cover the landscape with machinery far beyond what the ore itself required. At the beginning, however, there was only urgency. To turn a drill hole into a mine, men had to sink a shaft wide enough for workers, tools, timber, ore, and water equipment. Underground rooms had to be opened in the limestone. Rock had to be brought to the surface, broken apart, and sorted until the useful minerals could be separated from everything around them. Power machinery, lumber, cables, pumps, and rail connections followed the discovery because the metal was worthless until it could leave the ground. People followed for the same reason. State newspapers described Picher as a town born overnight. That phrase concealed several years of hard construction, but it captured the speed with which the place appeared. Mining crews needed housing. Companies needed offices and supply yards. Merchants needed counters from which to sell boots, food, tools, and work clothes. Streets were laid across land that had recently been identified by allotment boundaries rather than city blocks. The settlement took the name Picher. It did not take the name of Harry Crawfish, whose allotment was tied to the original strike. It did not take the name of Tar Creek, the waterway running through the field. It was named for O.S. Picher, associated with the company whose drill had reached the ore. The name arrived with the capital, equipment, and leases. The distinction would last longer than the company town itself. Harry Crawfish remained in the records as the owner of the allotment. Picher went on to maps, railroad schedules, business signs, school buildings, water bills, and birth certificates. One name identified the ground on which the discovery had been made. The other identified what the discovery built. By then, events far beyond Oklahoma were increasing the value of what lay beneath it. War began in Europe in 1914. Armies needed lead for ammunition, and zinc for brass, and for coating steel against corrosion. Every new report of fighting strengthened the market for metal from a field whose boundaries were still being tested. When the United States entered the war in 1917, Picher was no longer a speculative drilling site. It was becoming a national source of strategic material. The city incorporated in March 1918. That date is worth placing beside the disputed date of the strike. At most, 5 years separated a drill hole on a Quapaw allotment from a legally recognized Oklahoma municipality. By the federal census of 1920, Picher would have 9,726 residents. The surrounding county had gained more than 25,000 people in a decade, most of them drawn by the mining field. But incorporation did not make Picher an ordinary city. Its shape had not been determined first by a courthouse square, a river landing, or a railroad depot. The surface followed the mineral. Streets bent around industrial property. Homes stood near shafts and mills, because that was where the work was. Legal parcels on the surface became separate points of entry into one connected body of stone below. The company had found more than a deposit. It had found enough ore to require a city. Across the former allotments, derricks rose above new shafts. Beside them came the mills, each occupying its own measured piece of ground, one 40-acre square after another. One 40-acre square after another, the Picher field filled with machinery. By 1927, the Oklahoma Historical Society records 248 ore reduction mills operating around Picher. They were not arranged in one industrial district beyond the edge of town. The leasing system placed them across the mining field, each tied to a separate tract of land. A shaft, a derrick, a mill, a settling pond, and a growing pile of discarded rock could occupy one parcel, while another set stood on the next. 248 is easy to hear and difficult to picture. It meant that the industrial landscape did not have a clear beginning or end. A person leaving a house could pass a mill on the way to a store, then another beyond the next group of buildings. Towers rose over the shafts. Conveyors and ore bins stood beside them. Rail spurs reached toward the larger transportation lines. The mills were not merely outside Picher. In practical terms, they were Picher. The work began below ground. Most of the mines used a method known as random room and pillar mining. Miners cut large rooms through the ore-bearing rock, but left columns of stone standing to support the roof. The position and size of those pillars depended on the shape of the deposit, the judgment of the operators, and how much valuable rock could be removed without bringing the ceiling down. Across the field, approximately 1,200 vertical shafts were eventually sunk to depths ranging from about 90 to 350 feet. Each shaft was a narrow connection between two different versions of Picher. On the surface were streets, homes, payroll offices, and mills. Below were chambers, haulageways, support pillars, pumps, cables, and men working beneath several hundred feet of limestone. The rock came up mixed together. Galena carried the lead. Sphalerite carried the zinc. But most of what emerged from a shaft was not metal. It was limestone, chert, and other material surrounding small portions of valuable mineral. A mine could not send that raw mass directly to market. The mill had to separate a small, profitable fraction from everything that had been lifted with it. First, the ore was broken into smaller pieces. Crushers reduced the stone until the minerals could begin to separate from the surrounding rock. Early Picher mills relied heavily on gravity. Jigs moved crushed ore through water so that heavier mineral particles settled differently from lighter waste. Shaking tables continued the sorting, moving material across sloped surfaces until lead concentrate, zinc concentrate, and ordinary stone traveled in separate directions. The process was mechanical, repetitive, and loud. Rock entered in coarse pieces. Belts and bins carried it between machines. Jigs pulsed. Tables shook. Water moved constantly through the system. At the end, the metal-bearing concentrate occupied only a fraction of the original volume. It could be loaded and shipped toward smelters, where heat would separate the metal from the remaining impurities. Everything else stayed near the mill. The coarse waste was locally called chat. It consisted largely of pale, gravel-sized, and sand-sized pieces of crushed rock. At first, it accumulated as a practical byproduct, tipped beside the mill because it had no place in the shipment leaving Picher. Each working day added another layer. A pile began as a low bank near a conveyor. Then it widened. Then it rose high enough to become part of the horizon. Water carried away the finer material. Mill ponds collected mud and particles too small for the early gravity equipment to recover. To the companies, those ponds and chat piles represented what the first pass through the mill had failed to sell. They were not yet understood as the permanent geography of the town. They were the remainder. In the 1920s, flotation changed the calculation. Ore and finely ground tailings could be mixed with water and chemicals, then aerated. Bubbles attached themselves to selected mineral particles and carried them upward, where the mineral-rich froth could be collected. Material that had once been too fine for jigs and tables could now be processed again. The new method recovered more lead and zinc from every ton of rock. It also encouraged companies to grind material more finely and to rework some of the old tailings. A pile that had seemed finished could be opened again because technology had found a way to extract another small percentage of value from it. The logic was difficult to resist. A mill that recovered more mineral made a low-grade body of ore worth mining. A deposit that remained profitable kept shafts open. Open shafts kept workers employed and the city expanding. Every improvement increased the amount that could be taken from beneath the ground. It did not eliminate what remained above it. By the end of the decade, the arrangement of one mill for each small lease was beginning to look inefficient. In 1929, the Commerce Mining and Royalty Company built Ottawa County's first centralized mill west of Picher. That single plant replaced 12 smaller mills. Soon afterward, Eagle Picher built another central mill north of Commerce, described at the time as the largest and most modern lead and zinc concentrating mill in the world. Centralization would eventually reduce the number of mills. It would not reduce the scale of mining. Larger plants could receive ore from multiple shafts, process lower-grade rock, and continue working after smaller operations could no longer compete. The machinery became more efficient just as the richest deposits began to require more effort to reach. But in 1927, that consolidation still lay ahead. The Picher field was a grid of separate leases, each reaching downward through its own shaft and upward through its own mill. Beneath the surface, miners were opening rooms through the Boone Formation. Above it, crushers and jigs separated the fractions that could be sold from the much larger mass that could not. The lead and zinc departed. The stone began to stay. 14,252. That was Picher's recorded population at its peak in 1926. The town had been incorporated for only 8 years. In the federal census of 1920, it contained 9,726 people. During the next 6 years, it added more than 4,500, enough to fill another Oklahoma town without slowing the growth of the first one. The expansion reached far beyond Picher's city limits. Ottawa County had counted 15,713 residents in 1910 before the Great Strike near Tar Creek. By 1920, it held 41,108. In 1 decade, the mining field had drawn more than 25,000 additional people into a county at the extreme corner of the state. They came because Picher paid. At the height of activity, more than 14,000 men worked in the mines of the Picher field. Another 4,000 worked in approximately 500 businesses that supplied or served the industry. The combined workforce was larger than the entire population of Picher because many of the people descending into its mines did not live inside the town. They arrived by road and rail, and especially by interurban trolley. The electric system extended through the mining district and reached as far as Carthage, Missouri. Workers could live in another town, cross a state line, and still report for a shift beneath Picher. The city was not merely a settlement beside several mines. It was the center of a labor market spread across northeastern Oklahoma, southeastern Kansas, and southwestern Missouri. If you had ridden one of those cars toward Picher, the industrial landscape would have announced the destination before any city sign did. The derricks and mills appeared first. Then came the ore bins, rail spurs, ponds, and piles of crushed stone. The town stood among them, its homes and commercial blocks inserted into a field already claimed by machinery. Connell Avenue became the main business street. Money earned underground passed through stores, banks, restaurants, and boarding houses above it. Mining companies purchased timber, cable, pumps, drills, explosives, replacement machinery, and fuel. Workers bought boots, food, clothing, furniture, and the ordinary things required to turn a temporary camp into a place where families stayed. The city needed water as much as the mills did. O.S. Picher provided its first deep well, forming the beginning of a municipal water system. That was an early sign that the settlement no longer expected to disappear when the first profitable pocket of ore was exhausted. Streets and water lines assumed a future. So did schools, churches, and houses built within sight of the mills. Below them, the rooms continued to widen. The field's output reached extraordinary levels. In 1925, the mines produced approximately 387,000 tons of recoverable zinc and 101,000 tons of recoverable lead. Those figures describe concentrate, not the much greater mass of ordinary rock that had to be removed and milled to obtain it. Nearly 500,000 tons of usable metal came from the district in 1 year. The production had already connected Picher to events far beyond Oklahoma. More than half of the lead and zinc consumed in the United States during the First World War came from the Picher field. Lead went into ammunition and industrial products. Zinc entered brass and coated steel against corrosion. The same concentrates also moved into paint, roofing, linoleum, ceramics, batteries, and other goods that gave no visible indication of where their metal had begun. Picher was present in objects that would never carry its name. The ore left the field in concentrated form. Smelters converted it into metal. Manufacturers shaped that metal into cartridge components, sheet products, coatings, and machinery. The finished goods traveled across the country and overseas. Value moved outward through each step. Wages and royalties moved back in, though not evenly. Mining companies controlled much of the production. Individual quopah owners and their heirs held many of the restricted allotments beneath the field, while federal rules governed their leases. Workers sold their labor by the shift. Merchants depended on the money those shifts brought to town. Picher contained several different economies layered over the same deposit, each receiving a different portion of what came out of the ground. For the city, the arrangement worked as long as the mills ran. A shaft required miners, hoist operators, timbermen, pump crews, and mechanics. A mill required men to operate crushers, jigs, tables, conveyors, and flotation equipment. The finished concentrate required loaders and transportation. The workers required food, housing, schools, repairs, and entertainment. One job underground supported others above it, and those jobs drew still more people into Picher. The growth appeared self-sustaining. More ore meant more workers. More workers meant more houses and stores. More businesses made the town a larger market. A larger town justified more infrastructure. By 1926, the original drill hole on Harry Crawfish's allotment had become difficult to locate within the industrial system it had created. There were signs that Picher's abundance carried its own limits. The richest ore could be removed only once. Every room opened beneath the town enlarged the space that had to be supported by pillars and kept dry by pumps. Every ton sent to a mill produced a far greater quantity of stone that could not be sold. But those were not yet the numbers by which Picher measured itself. The number that mattered was 14,252. It counted the people sleeping within the city, not the thousands commuting into it. It did not count the chambers beneath their streets. It did not count the crushed rock accumulating beside their homes. It described a town at its fullest moment, when the trolleys were carrying men toward the mines, and the mills were separating metal from stone as quickly as machinery allowed. The metal left. Around Picher, the remainder was beginning to form mountains. The mills did not merely process the Picher field. They changed its elevation. Between 1891 and 1970, United States Bureau of Mines records show that approximately 181 million tons of crude ore were removed from the district. From that mass came about 8.9 million tons of zinc concentrate and 1.7 million tons of lead concentrate. The arithmetic left roughly 170.5 million tons behind. For every ton of lead and zinc concentrate recovered, the field produced more than 16 tons of waste rock. The metal was valuable because it occupied such a small part of what came up the shafts. The mills existed to identify that part, separate it, and send it away. Everything else had to go somewhere. The coarser material came out of the mills as chat, a mixture of fine gravel and rough sand made largely from crushed limestone and chert. Conveyors carried it away from the processing equipment and dropped it beside the mill. A fresh pile began close to the ground. As the crusher continued running, the crest rose and the side spread outward. There was no single moment when a pile became a hill. Each shift added another layer. Each new room underground brought more stone to the surface. A mill could recover only the lead and zinc particles its machinery could separate. The rest accumulated until the waste pile stood above the buildings that had created it. Some piles eventually approached 200 feet in height. They were too large to be hidden behind fences or moved beyond the town. The mills had been distributed across the mining field according to the old 40-acre leases, so the piles were distributed with them. They appeared beside roads, industrial yards, houses, and schools. They filled views that before the strike had ended in low prairie. The fine waste formed another landscape. Milling required water. Jigs and tables separated particles by weight, while flotation equipment recovered mineral from finely ground material. The water leaving those systems carried mud-sized particles into ponds. As the water evaporated, the bottom became a bed of fine tailings containing the minerals that the mill had not recovered. The coarse chat formed slopes. The fine tailings formed flats. Neither was treated as an emergency. During the working life of the mines, both were evidence that the machinery was doing what it had been built to do. The concentrate leaving Picher paid wages, royalties, freight bills, and company profits. The material remaining beside the mill had no comparable entry in the account book. It was simply there. Some of it was not even considered useless. Chat had the size and texture of construction aggregate, and the district possessed it in quantities no quarry could match. It was spread across roads, parking lots, alleyways, and driveways. It was used as general fill where the ground needed to be raised or leveled. A product the mills could not sell as metal became a convenient local building material. That decision brought the mining field into the town one truckload at a time. A family did not need to live beside a towering pile to come into contact with chat. It could be beneath the automobile in the driveway, behind a building, or packed into an alley. It could form the base of a parking area or the surface of an unpaved road. The waste did not remain at the point where the conveyor dropped it. It traveled wherever cheap gravel was needed. The large piles became familiar in another way. Children climbed and played on them. Later federal records would include photographs of children on the slopes and call for warning signs near piles that had been used for recreation. Schools would eventually receive programs telling students to stay away from them. Those warnings belonged to another period. During Picher's working years, the pale slopes were part of the place. They offered height in a town built on nearly level ground. Their loose surfaces carried footprints, bicycle tracks, and the marks of trucks removing material for road work. The mines were the reason the town existed. Their waste was therefore not separate from local life. It was the ground on which part of that life occurred. The danger lay in particles too small to define the landscape. Raw chat still contained lead, zinc, and cadmium. Tests conducted decades later found that the smaller the particles became, the greater their metal content tended to be. Coarse stone might remain where it was placed. Finer material could become dust. Wind moved it from the pile surface. Tires and footsteps disturbed it from roads and driveways. Rain passed through the slopes and carried dissolved metals into nearby drainage. The same crushing process that made the waste useful as fill had also created material small enough to leave its original location. Picher did not need one broken dam or one collapsed waste pile for the contamination to spread. The ordinary movement of air, water, vehicles, and people was sufficient. Even after decades of reprocessing and commercial removal, the scale remained difficult to contain. A 2005 federal inventory identified 83 standing chat piles occupying 767 acres. It also found 243 chat bases, the footprints of former piles, covering another 2,079 acres. 63 fine tailings ponds occupied approximately 820 acres. The missing piles had not necessarily disappeared. Some had been milled again when flotation made it profitable to recover particles the older equipment had missed. Some had been sold or moved for aggregate. Their former bases remained, holding fine waste against the surface even after the recognizable hill had been reduced. This was the peculiar efficiency of Picher. New machinery could recover more metal from old waste, but each improvement extended the life of mining and produced another remainder. A pile could be processed twice and still leave material behind. By the time the mines began to decline, the district had exported millions of tons of lead and zinc. Those metals had been dispersed through factories, armies, cities, and consumer goods across the country. Picher retained the physical record of what their production required. The record stood beside the town in slopes nearly 200 feet high. It lay beneath tires in the alley. It settled into ponds. It moved as dust across yards and as runoff toward the creeks. The mills had made the mountains. Picher had learned to live among them. In February 1950, the Plaza Theater in Picher stopped showing movies. The closing was unusual enough to reach Variety, the national entertainment newspaper. The Plaza had not lost its film supply. Its projection equipment had not failed. The building had not burned, and the manager was not waiting for a larger audience. The ground beneath it was becoming unsafe. The Plaza contained 1,000 seats, enough to hold roughly one person for every 6 residents counted in Picher a decade earlier. It stood within a 4-block section of the business district underlain by abandoned mine tunnels. Eagle Picher Mining and Smelting Company warned that the stone pillars supporting those workings showed signs of strain. The company feared a cave-in. Lawrence Wells, the theater manager, closed the plaza until the area could be declared safe. Variety noted that it was the only business in the 4 threatened blocks to stop operating. The other stores and offices remained open above the same mine workings. That is how the danger first entered daily life, not with the collapse of an entire street, but with a dark theater and a locked door. The mine rooms beneath those 4 blocks had once represented productive space. Every chamber was a place from which valuable rock had been removed. The pillars had been left behind to hold up the roof while mining continued around them. As long as the companies needed access, engineers and miners had reason to watch the workings, remove water, and maintain equipment. An abandoned room was different. It no longer produced ore. It carried no payroll. Its remaining value lay in the fact that it did not collapse. By 1950, Picher had been shrinking for more than 2 decades. The population had reached 14,252 in 1926, then fallen to 5,848 by 1940. The Great Depression reduced demand and tightened the industry, while central mills replaced clusters of smaller operations. 12 local mills could disappear when one larger plant took over their work. More ore could be processed with fewer buildings and fewer crews. The Second World War increased demand again. Lead and zinc were strategic materials, and the Picher field returned to heavy production. But wartime demand did not restore the city to its former size. The best deposits had already been worked for years, and every new ton required companies to handle rock containing a smaller proportion of useful mineral. Near the end of the district's productive life, useful ore could make up only a small fraction of the material brought to the surface. The mills had become better at extracting it. Flotation could recover metal from finely ground rock and even from waste left by earlier machinery. That efficiency allowed the mines to continue. It could not replace the ore already gone. After 1946, production declined sharply as the highest grade deposits became depleted. The federal government ended premium payments for strategic minerals in 1947, removing support that had helped make expensive production worthwhile. Metal prices weakened. Demand changed. A field that had supplied war industries now had to compete as an aging source of increasingly costly ore. The city had few alternatives. In another place, declining mines might have left large tracts available for factories, warehouses, or new housing. Picher's real estate was more complicated. Much of it belonged to restricted Quapaw owners and heirs, making sales and development dependent on legal arrangements beyond an ordinary property transaction. The surface was also broken into old mineral leases and industrial parcels. Then there was the ground itself. Mine workings extended beneath large parts of the town. New employers considering a building site had to contend with shafts, boreholes, abandoned rooms, and uncertain support pillars. The same underground network that had allowed Picher to grow made it difficult to build an economy after mining. The town had been designed around access to what lay below. Once that material lost its value, the design offered little else. Most major mining activity ended in 1958. Smaller operations continued through the 1960s, working remaining deposits and material that improved milling could still make profitable. Local histories commonly give 1967 as the end of lead and zinc mining at Picher. Federal records note that the last significant production in Ottawa County occurred around 1970. There was no single final shift shared by the whole field. One shaft stopped, then another. A mill closed or was replaced by a larger plant. A crew became smaller. Equipment was removed from a property that still contained rooms hundreds of feet below the surface. The population followed the work. By 1960, Picher held 2,553 people, fewer than one-fifth of its 1926 peak. Houses remained where miners no longer received paychecks. Commercial buildings remained where fewer customers walked through the doors. The chat piles did not shrink with the population, neither did the mine rooms. The Plaza Theater had made that imbalance visible. A building created to hold 1,000 people had been closed, because stone removed decades earlier was still determining what could happen above it. The warning did not require anyone to understand groundwater chemistry or heavy metal contamination. A theater patron needed only to know that the floor might not be as permanent as it looked. Picher continued after the plaza closed. Residents raised families, attended school, opened businesses, and used streets laid over a minefield. The city did not become empty when production ended. It became a place where the structures of ordinary life remained attached to an industry that was leaving. Underground, the old rooms still required one final service. Mining in the Boone Formation had always fought water. Pumps ran continuously to keep groundwater from filling the shafts and chambers. While ore was valuable, the cost of pumping was part of doing business. When the last profitable workings closed, there was little reason to keep paying for dry rooms no one intended to enter. The machinery stopped. Below the silent theater, the water began to rise. When the pumps stopped, the mines did not fill at once. Groundwater entered slowly through the surrounding rock. Rain and surface water found abandoned shafts, ventilation holes, exploratory boreholes, and places where the ground had already subsided. The same openings that had once carried men and equipment into the Picher field now carried water down. There was room for an extraordinary amount of it. Local histories estimate that the abandoned workings accumulated approximately 76,800 acre-feet of mine water. The water spread through rooms and passageways that had been opened over more than half a century. As the level rose, it covered exposed surfaces containing iron, lead, zinc, cadmium, nickel, and other minerals left behind by mining. The chemistry continued in the dark. Sulfide minerals exposed to air and water began to oxidize. The mine water became acidic enough to dissolve additional material from the surrounding rock. Its concentrations of sulfate dissolved solids, and metals increased. What had once been ordinary groundwater entered the workings, remained there, and came into contact with the unfinished interior of the mining field. For years, most of that process remained below the surface. Oklahoma historical records report contaminated seepage beginning as early as 1973. The event that drew the attention of state and federal agencies came in 1979. When mine water began flowing from abandoned shafts and boreholes near Commerce. Other discharges appeared near Tar Creek and the former mining settlement of Douthat. The mines had filled high enough to overflow. Tar Creek begins in Kansas and runs south for approximately 11 miles through the old mining district. It passes between the communities that had depended on the Picher field, then continues toward the Neosho River. Before the mines overflowed, it was a small local waterway. People fished in it. Its pools and banks belonged to ordinary life rather than federal environmental records. Rebecca Jim arrived in the area in 1978 to work as a counselor for Native American students. She later remembered that one of her students had been fishing in Tar Creek the day before the water changed. The next day, the fish were dead. The creek was orange. The color did not come directly from lead or zinc. Iron-rich mine water reached the surface and met oxygen. The iron oxidized and formed deposits of ferric hydroxide, the same basic process that produces rust. The water turned brownish-orange, while red material settled across the creek bed. It stained everything it touched. Rocks in the channel changed color. Tree trunks and bridge to supports carried orange marks where the water reached them. Farther downstream, red staining appeared on bridge abutments and even on cliffs along the Neosho River below its meeting with Tar Creek. The color made the damage impossible to keep underground. A resident did not need laboratory equipment to see that the creek had changed. The water itself had become a warning sign running through the district. The visible iron was only part of what it carried. Testing found lead, zinc, cadmium, nickel, sulfate, and other dissolved material in the mine water. Most aquatic life downstream in Tar Creek was killed. The creek continued flowing, carrying water and contaminated sediment away from the abandoned shafts and toward larger rivers. Mining had once moved metal out of Picher by rail. Now water was moving what remained. In 1980, the governor of Oklahoma created the Tar Creek Task Force, bringing together local, state, and federal agencies to investigate the mine drainage. Congress passed the Federal Superfund Law that same year, creating a system for identifying and cleaning hazardous sites whose responsible companies might no longer exist or possess enough money to repair the damage. Tar Creek became an early test of that system. The Environmental Protection Agency proposed adding the area to the National Priorities List in July 1981. On September 8, 1983, the designation became official. The site covered approximately 40 square miles of northern Ottawa County. Picher stood near its center, but the contaminated water and mining waste did not follow municipal boundaries. Carden, Commerce, North Miami, Quapaw, and rural properties were part of the same landscape. The name attached to the federal site was not Picher, it was Tar Creek. That choice placed the orange water at the center of the first cleanup strategy. The initial federal plan called for plugging abandoned wells that might allow contaminated mine water to reach the deeper Rubidoux Aquifer, the source of municipal drinking water. It also called for diverting surface water away from openings where it could enter the mines. Dikes were built, and dozens of abandoned wells were plugged. The goal was to separate one body of water from another. Clean water below, contaminated mine water above it, surface flow outside the shafts. But the underground workings were too extensive to empty or seal as a single structure. More abandoned wells continued to be found. Mine water continued to require monitoring. The creek remained orange. Its color told the simplest version of the problem. Water had entered the mines, dissolved what mining left exposed, and returned to the surface, carrying metal with it. That sequence could be followed from a shaft opening to Tar Creek and from Tar Creek toward the Neosho. Other routes were harder to see. Dust moved from chat piles into homes. Fine waste lay beneath roads, alleys, parking lots, and yards. Children could touch contaminated soil without ever approaching the Orange Creek. The first Superfund work concentrated on groundwater and mine drainage, because that was the damage the district had announced most clearly. The creek had changed color in a day. It would take much longer to discover what had entered the children. Tar Creek announced its contamination in orange water, dead fish, and iron stains that clung to rocks. Lead did not announce itself at all. A child could run across a chat-covered yard, wipe a hand across a dusty windowsill, eat supper, sleep through the night, and wake without fever or pain. The evidence appeared later in a laboratory number, measured in micrograms of lead, carried through 1/10 of a liter of blood. By then, the waste from Picher's mines had been above ground for generations. Chat lay beneath driveways, alleys, parking lots, school grounds, and patches of lawn where grass grew thin. Wind lifted the finest grains from the piles. Tires carried them into streets. Shoes brought them across porches and onto floors, where the particles settled among crumbs, lint, and the ordinary dust of a household. For an adult, that dust was dirt to be swept away. For a small child, it was part of the floor. Children younger than 6 touch the ground, handle toys, and place their fingers in their mouths with a frequency no public health model can make picturesque. Their bodies are still forming. Lead can interfere with the brain and nervous system before the damage produces any obvious outward symptom. And even low levels have been associated with developmental delay, difficulty learning, and behavioral problems. There is no blood lead level now considered safe for a child. In 1994, the Indian Health Service tested Native American children living in the Tar Creek area. 35% had blood lead levels above 10 micrograms per deciliter, the federal level of concern used at the time. The percentage did not describe every child in Picher, nor every child in Ottawa County. It described the Native children who were tested. Even with that boundary, the number was difficult to absorb. Roughly 1 child in 3 had crossed a line that federal health officials then used to trigger concern. Another study of young school children in the area found elevated levels in more than 43% of those examined, about 11 times the Oklahoma average. These were not measurements from creek sediment or a pile of mine waste. They were measurements taken from children. The old threshold requires explanation. 10 micrograms per deciliter was not a border between poisoned and unpoisoned blood. It was an administrative marker based on the knowledge and public health practice of the period. The current federal reference value is 3.5 micrograms per deciliter, and the Centers for Disease Control and Prevention states that no safe level has been identified. A child below the old line did not therefore carry no lead. The child simply fell below the number officials were then using. The blood tests redirected attention from the Orange Creek to the gray ground. Between August and October of 1994, the Environmental Protection Agency examined 28 places where children gathered: playgrounds, daycare grounds, school property, parks, and similar high-access areas. 17 were judged to require some form of response. Investigators found lead in the surface soil, along with cadmium and other metals left by the mining process. Residential testing widened the picture. Federal investigators evaluated 2,055 homes in Picher, Cardin, Quapaw, Commerce, and North Miami. At about 65% of them, at least one part of the yard contained lead at or above 500 parts per million. That could mean the soil beside a swing set, the bare strip along a driveway, or the patch between a back door and a clothesline. The contamination did not have to cover the entire property. A child did not play evenly across an entire property either. Mine tailings were not the only possible source. Many houses in the district were old enough to contain lead-based paint, another source of contaminated dust. But the investigation found that soil in Picher yards and gardens averaged about 10 times the lead concentration measured in the comparison community of Afton. The Environmental Protection Agency's risk assessment identified contaminated soil as the greatest human health threat at the site. The material that had once been sold and spread as cheap fill had become a pathway into the body. In the summer of 1996, cleanup crews began entering residential yards. They removed contaminated earth in layers 6 inches deep, tested the newly exposed surface, and dug again when the lead remained above the cleanup level. Excavation could continue to 18 inches. If contamination still remained at that depth, workers laid down a barrier before replacing the missing ground with clean topsoil. The work had the strange precision of surgery performed on a town. Shrubs were removed and replaced. Bare earth was watered to hold down dust. Dump trucks carried covers so contaminated soil would not blow back across the streets. Grass seed or sod went down over the new surface. A yard could look much as it had before, although beneath the clean soil a buried marker might remain, warning anyone who dug there later that the old ground had not disappeared. Federal officials chose 500 parts per million as the soil cleanup level intended to protect children under the standards and exposure models then in use. The number was not the natural condition of an uncontaminated prairie. It was the line at which excavators stopped. The response extended beyond machinery. The Quapaw Nation sought federal assistance after the childhood testing results and established its environmental office in 1997. Health workers encouraged blood testing and tried to reduce the daily movement of contaminated dust through homes. Families were told to wash children's hands, clean floors and toys, leave dusty shoes outside, and keep children away from chat piles and bare contaminated soil. These were small domestic defenses against mountains that mills had spent decades building. The blood measurements changed. In 1996, 31.2% of tested children between 1 and 5 years old at the Tar Creek site had levels above the old 10 microgram threshold. By 2003, the figure was 2.8%, 7 children among 250 tested. Soil removal, health education, declining exposure, and other lead control efforts had altered what laboratories were finding. They had not made the history vanish. A lower percentage did not tell what earlier exposure had already done to any particular child, and it did not mean the remaining ground was free of lead. It showed that removing contaminated yards could interrupt one route from the mines into the blood. The town had learned to measure danger in a creek, then in soil, then in children. But while crews could lift 18 inches of earth from a yard and replace it with grass, the chambers beneath Picher remained where the miners had left them. The soil could be removed. The ground beneath it was another matter. The clean soil placed over Picher's yards reached down as much as 18 inches. Beneath it, the old workings reached from roughly 90 to 380 feet below the surface, and in places the rooms carved through the Boone Formation were large enough to hold buildings. Some were 125 feet high. Some extended 1,000 feet across. The town stood on the ceiling. During the mining years, that ceiling had been supported by columns of unbroken rock. The room and pillar system was simple in principle. Remove the ore, leave enough behind to carry the weight above. But every pillar represented metal that had not been sold. Miners sometimes shaved them narrower, gouging ore from their sides. In other places, pillars were removed during later work. The final underground shapes were not always recorded on the mine maps. A house on the surface might therefore stand above a solid column, an open room, a weakened pillar, or an arrangement no living engineer could see clearly. The front porch gave no indication. Picher had known this danger long before the federal study. In 1950, 5 blocks in the business district were ordered vacated after mine supports showed signs of strain, closing the Plaza Theater and leaving a fenced opening in the middle of town. In 1967, another collapse dropped an acre and a half of ground about 25 feet. Residents learned where not to walk, where not to build, and which depressions had appeared since the last hard rain. The restrictions accumulated one parcel at a time. A baseball field was abandoned. Houses near the grade school were cleared. 2 blocks north of them received 30-day notices. The town continued around these holes because a local danger could be fenced, avoided, and eventually absorbed into memory. What Picher did not have was a map showing whether the exceptions were becoming the rule. In June 2004, Senator Jim Inhofe requested a systematic evaluation of the subsidence hazard, and the United States Army Corps of Engineers became the lead agency. Engineers, geologists, mining specialists, state officials, the Bureau of Indian Affairs, the Quapaw tribe, and other participants began assembling the town beneath the town. They collected 173 mine maps from federal land records, another 348 from the Picher Mining Field Museum, and more than 500 from the archives of Missouri Southern State University. They added logs from over 3,800 exploratory boreholes, old aerial photographs, records of previous collapses, and the recollections of retired miners. Paper drawings made for extracting ore were converted into a three-dimensional model of what remained after the ore was gone. The gaps in the record mattered. Mine maps showed planned rooms and pillars, but they did not always show the later shaving or removal of those pillars. Some collapses before 1960 had never been formally recorded. Water now filled workings that inspectors could once have entered. The study could estimate the danger. It could not look under every house. In January 2006, the team issued its report. The number later repeated in accounts of Picher was 86%. 86% of the town's buildings were said to be undermined and vulnerable to collapse. The report itself described the result more carefully. It identified 159 residential, commercial, and public use structures in Picher that stood above, or within 150 feet of, locations where some degree of subsidence was estimated. That inventory included 139 residences, 11 businesses, 6 churches, the city maintenance facility, a lodge, and the Picher Mining Field Museum. 53 streets crossed or approached potential subsidence areas. So did portions of the main transportation routes through town. The old theater had not been an isolated mistake. It had been an early reading. At Reunion Park, the estimated maximum drop exceeded 50 feet. Near the elementary school, a playground sat beside an area where the model indicated a possible collapse of 25 to 50 feet. The site had already been marked as restricted on an Eagle Picher mine map, and residents had been ordered away from nearby blocks in 1968. In 2004, part of the land had been made into a playground. 2 generations had placed different meanings on the same ground. The report did not predict that every listed building would fall, or name a date when collapse would come. Subsidence depended on the width of a mine opening, the thickness and strength of the rock above it, the condition of the pillars, groundwater, and failures that could transfer weight from one support to the next. A single pillar breaking could load its neighbors. If they yielded in sequence, the failure could travel underground like a row of doors closing in darkness. Nor was filling the mines an easy answer. The workings spread beneath thousands of acres and contained rooms whose exact dimensions were uncertain. Reaching them would require drilling through contaminated ground and pumping enormous amounts of material into openings already filled with mine water. Reinforcing a school, a highway, or one public building might be possible. Reinforcing a town was another calculation. The study listed relocation among the available responses. Its language was plain. Moving residents would not correct the subsidence problem. It would remove people from daily contact with it. A smaller relocation program had already begun in 2005 for families with children younger than 6. 60 families in Picher, Cardin, and Hockerville accepted buyouts averaging about $51,000 each. More than 90% of the eligible families participated. Enrollment in the Picher-Cardin schools fell by 1/4. That number is worth pausing over. The first visible effect of the buyout was not an empty house. It was an empty desk. After the 2006 report, relocation widened. Properties had to be identified, inspected, appraised, offered, accepted, and transferred. The process converted kitchens, workshops, porches, and family lots into files with parcel numbers and dollar values. Some residents wanted out immediately. Others questioned the appraisals, distrusted the agencies, or could not imagine exchanging a house they owned for a payment that might not purchase an equivalent one elsewhere. A voluntary buyout also changed the value of what remained. Each family that left reduced the number of customers at the grocery counter, children in the school, worshipers in the pews, and taxpayers supporting streets and water lines. The government could purchase houses one at a time, but the town functioned as a collection. Remove enough pieces, and the distance between them became the dominant feature. By 2007, Picher still had a city hall, a school, churches, businesses, water lines, stop signs, and residents mowing grass beside vacant houses. Connell Avenue still ran through downtown. The water tower still carried the town's name above the roofs. But beneath those roofs, the mind maps were now part of every decision. Repairing a building, selling a home, replacing a sewer line, or reopening a vacant lot meant consulting the geometry underground. Picher had been created because of what lay beneath 40 acres. It was now being dismantled for the same reason. In the spring of 2008, the buyout was still unfinished. At about 5:40 on the afternoon of May 10, 2008, an enhanced Fujita 4 tornado entered Picher from the west. It crossed the town quickly enough that one house could be left standing, while the next was reduced to boards, insulation, clothing, and broken glass. About 200 homes were destroyed. 6 people were killed, and approximately 150 were injured. The buyout had not yet finished. The weather did not wait. A later damage survey counted 166 conventional houses and 66 manufactured homes inside the tornado's path. Nearly 3/4 of the manufactured homes were destroyed. Some had been fastened with rock anchors designed to grip solid rock or coral, but the crossed steel rods had been driven into unconsolidated soil. Anchor heads slipped free. Other straps broke, leaving the steel undercarriages to roll or rise into the wind. Picher had spent nearly a century taking rock from beneath its houses. Now even the devices meant to hold those houses to the ground could not find enough ground to hold. Emergency crews arrived with the Oklahoma National Guard. The storm had cut electrical power and destroyed the municipal water system's testing equipment, forcing a boil notice. Rural water workers brought an emergency generator, and within 2 days the system was operating normally again. It was a precise, practical act. Restore water to a town the government was already preparing to empty. There would be disaster assistance, but officials said the destroyed homes would not be rebuilt with public money. Federal and state agencies continued supporting relocation. A family standing beside a bare foundation could receive help to leave Picher, but not to reconstruct the house on the same parcel. The tornado did not create that decision. It made the decision physical. The remaining institutions began to close in order. In April 2009, residents voted 55-6 to dissolve the Picher-Carden School District. Enrollment had fallen from roughly 343 students a few years earlier to 49. That May, 11 seniors formed the final graduating class. The hallways had once carried the children and grandchildren of miners. Now lockers stood unused. Classrooms were consolidated, and the gorilla mascot belonged to a school without another autumn ahead of it. By June, the relocation program had issued its final round of assistance, and most remaining property owners accepted. Some refused. A government could offer an appraisal and a check, but it could not make a kitchen in another town into the kitchen where 3 generations had eaten, or replace a porch with the same view down Connell Avenue. the post office closed. On September 2009, Picher ceased operating as an incorporated city. The legal dissolution was completed several years later, but the practical machinery of the town had already stopped. No mayor presiding over council business, no city workforce maintaining a future network of streets, no school district waiting for another class. The 2010 census counted 20 people inside boundaries that had held 14,252 at the peak. A population once large enough to fill grandstands, theaters, boarding houses, churches, and 248 mill sites had become small enough to fit inside one schoolroom. Demolition began in 2010. Excavators pushed walls inward. Trucks carried away roof timbers, brick, plaster, and metal. By 2011, historical accounts recorded 6 occupied houses and 1 business remaining. Empty lots appeared where neighborhoods had stood, their driveways ending at rectangles of grass. From above, the old street grid remained visible, but the buildings that had explained it were missing. The town disappeared faster than the mining field. As houses came down, the larger cleanup continued across the 40-square-mile Tar Creek site. Crews removed chat piles, excavated contaminated soil, capped shafts, plugged boreholes, reshaped ground, and tried to establish vegetation on surfaces where the mills had left gray waste instead of topsoil. Some chat could be sealed inside asphalt or concrete. Other material went to controlled disposal areas. Streams and sediment required a different set of plans. By January 2025, federal records showed that approximately 10.5 million cubic yards of mine waste and contaminated soil had been excavated across the site. More than 5,500 acres of private and tribal land had been remediated, and nearly 4,000 contaminated residential yards had been addressed. Those numbers describe movement on an industrial scale. They do not describe completion. The Environmental Protection Agency's 2025 plan still listed residential soil cleanup as ongoing. Work on surface water and creek sediment had not reached a final remedy. Millions of tons had been removed from the Beaver Creek and Elm Creek areas, while contaminated mine water continued to require treatment and monitoring. The work had lasted longer than Picher's final generation of municipal government, and federal planning extended it years into the future. The Quapaw Nation, whose allotted land had been divided into the 40-acre mineral leases on which the field was built, became one of the principal agencies carrying out the cleanup. Quapaw crews removed waste, shaped slopes, applied soil amendments, planted native vegetation, and managed work on tribal and private land through agreements with the Environmental Protection Agency. The land had passed from Quapaw ownership into leases, from leases into mines, from mines into waste sites, and then back into Quapaw hands for repair. Picher did not become an untouched prairie after its buildings vanished. Roads still crossed the former town. A Quapaw law enforcement office remained. A few residents continued living among the empty parcels. Chat piles still rose beyond the grass, and beneath them the flooded rooms, pillars, roof falls, and shafts remained part of the geography. If you drive north on United States Highway 69, the place does not arrive as towns usually do. There is no thickening line of storefronts, no school zone traffic, no row of houses announcing that the highway has become a main street. The open spaces simply begin to align with curbs, utility poles, and pieces of pavement. Connell Avenue still passes through blocks that once held the Plaza Theater, stores, lodges, and rooms rented by miners. Above the grass, the water tower carries the name Picher in red letters. Beyond it stand the pale remains of the mountains the mills made. The name is still in the air. The town is gone from the ground.